Good morning to all. Dear students, during the last class, we studied different types of chemical reactions. We already know that a chemical reaction, a chemical equation represents a chemical reaction. Such reactions are a combination, reactions, B. Decomposition reactions, C. Displacement reactions, D. Double displacement reactions. Double displacement reaction. There is one more reaction there, that is redox reactions. Before going to the redox reactions, we come across decomposition reactions. Decomposition reactions can be again divided into two. That is exothermic reactions and endothermic reactions. Exothermic reactions and endothermic reactions. Exothermic reactions are those reactions in which heat energy is liberated. Liberated. For example, burning of magnesium ribbon. Magnesium ribbon burns in oxygen to form magnesium oxide plus heat plus light. Heat energy can be represented by a symbol this symbol denotes heat energy. When magnesium ribbon burns in oxygen, it forms magnesium oxide and heat energy. Another example is when we add water to calcium oxide. When we add water to calcium oxide, calcium hydroxide is formed. At the same time, heat energy is also liberated. These are examples of exothermic reactions. You can, from the where itself, you can identify exo. Exo means, I already said to you, exo means exit. Thermo means temperature, thermometer. So exothermic reactions, from the words itself, we can define that those reactions in which heat energy is liberated. For example, burning of magnesium ribbon, reaction between calcium oxide and water. Calcium oxide, it is also known as, its industrial name is lime or quicklime. It is also called lime or quicklime. It is used for the production of cement. This calcium oxide, we have already seen this activity. Some calcium oxide is taken in a beaker and add some water. Then calcium hydroxide is poured. When we touch the outside of the test tube, we can feel heat in the outside test tube. This means by reaction, the reaction between calcium oxide and water, when calcium hydroxide is formed and at the same heat energy is liberated. This calcium hydroxide is known as slated lime. lime calcium oxide, it undergoes slaking to form the product slacked lime. This slacked lime is used for whitewashing of house. This slacked lime is used for whitewashing house. The walls of your home, its color is white. But this color, now it is not calcium hydroxide. When we whitewash calcium hydroxide, within 2-3 days, this calcium hydroxide slowly reacts with the carbon dioxide present in air to form calcium carbonate. So, while we are whitewashing, the powder is taken about calcium hydroxide in the powdered form. It is mixed with water. I am using a brush, the painter whitewash all of the walls. After 3 days, when we use a blade, we can beat it with the little blades. Now it is called calcium carbonate. In your test book, there is a question. When you read a question, you go deep into the question. A solution of a substance named Hmcs is used for whitewashing. You clearly understand? A solution of a substance Hmcs is used for whitewashing. Which is substance? Calcium oxide or calcium hydroxide. The solution, in the question, the substance which is used for whitewashing, you have only one answer, calcium hydroxide. But here the question is the solution of a substance. Which is the correct answer? Calcium oxide. Calcium oxide, its solution is, when it is treated with water, calcium hydroxide. Therefore, X is calcium oxide. This is a twisted question. You can think it and find the answer. Yes, the substance used for whitewashing is calcium hydroxide. In your test book, what is asked? The solution of a substance named X is used for whitewashing. Solution means what? A substance soluble in water, then the solution will be obtained. This is exothermic reactions. The other is endothermic reactions. Endothermic reaction is just opposite to exothermic reactions. Those reactions in which heat energy is absorbed. For example, calcium carbonate on heating, it decomposes to give calcium oxide plus carbon dioxide. Calcium carbonate, കടൽ ജീവികളുടെയൊക്കെ ഷെല്ലുകൾ, കക്ക, ചിപ്പി, പവിഴപ്പുറ്റ്, that all are calcium carbonate. That calcium carbonate on heating, it decomposes to give calcium oxide and carbon dioxide. Here, the symbol heat is here. Calcium carbonate absorbs it, or it absorbs it and decomposes to give calcium oxide and carbon dioxide. Here, heat energy is absorbed. So, this type of reactions is called endothermic reaction. This is also called thermal reactions, but it is reaction brought out by thermal decomposition. By reaction brought out by absorbing is known as thermal decomposition. There is another term also, thermal decomposition. But in thermal decomposition, here also I already told you, thermal means this word denotes heat. Thermometer, the part is used for measuring heat. Thermometer. From this, we are on hearing thermal, exothermic. This thermic denotes always heat. But the thermal decomposition means the reaction brought out by absorbed heat is known as thermal decomposition. The decomposition of calcium carbonate is a thermal decomposition. It is a decomposition reaction. At the same time, it is also a thermal decomposition reaction. It means thermal decomposition In addition to thermal decomposition, there are when we pass electricity through the solution, it also decomposes. It is known as electrolytic decomposition. For example, we see that when electricity is passed through acidified water, it decomposes to hydrogen and oxygen. The another example given in this is ferrous sulfate, a PSO4. On heating, it produces ferric oxide plus SO2 plus SO3. In Standard 9, you have already studied how to write the molecular formula. SO2 means sulfur dioxide. SO3 means sulfur trioxide. So, what are the changes observed when we heat ferrous sulfate? HbSO4 plus heat. 2 HbSO4 on heating, it decomposes to give ferric oxide and SO2 and SO3. We take some ferrous sulfate in addition and heat for a long time. The green color of the ferrous sulfate turn to black, and at the same time a smell of sulfur is produced in the room. Green color ferrous sulfate turn to black colored ferric oxide. At the same time, a smell of sulfur is spread in the room. So, this is also a thermal decomposition. The reaction brought by absorbed heat is known as a thermal decomposition. During these decomposition reactions, there may be either heat energy, light energy, or electrical energy may be used. When the silver chloride placed a little kind of silver is taken and placed in in presence of sunlight, it turned grey, silver, and chlorine is evolved. Silver chloride, when exposed to sunlight, it turned grey and chlorine is exposed in presence of sunlight. Here the decomposition is brought out by sunlight. Similarly, when silver bromide is placed in presence of sunlight, it decomposes to give silver and bromine. This principle is used in black and white photography. About 5 years back, we all know that photo is taken by using ordinary camera. Now it is used digital camera. In ordinary camera, film is used. You already know. In that film, the silver bromide is plated over it. When the photo is taken, the silver bromide which the surface spread on them, it just decomposes and to give silver and bromine. Bromine is a gas and it goes there. This is the principle of the photography in ancient age. Ancient age means about 5 years, 10 years back. Then nowadays we use this digital camera in everywhere. So this is the other type of reactions. This is to identify that in decomposition reactions is carried out by either heat energy or light energy or electrical energy. If heat energy is used for absorbing decomposition reaction, it is known as thermal decomposition. The principle of photography is the substance spread the photographic film is silver bromide. Then it goes to the next reaction, redox reactions. It is a combination of two types of reaction. One, oxidation reaction. Two, reduction reaction. If two reactions are taking place simultaneously, it is known as redox reaction. Redox means reduction plus oxidation. That is known as redox reactions. In your test, activity is given to you. Take some copper granules in a china dish and heat it. On heating for some time, these copper granules turn black. What happened there? Or what is the changes there? On heating, copper combines with oxygen to form copper oxide. On heating copper in a china dish, this copper combines with the oxygen present in the air to form copper oxide. Copper oxide is black in. After heating sometime, it combines with oxygen to form copper oxide. Then there is another reaction. This copper oxide, when hydrogen is passed through this copper oxide, it again yields golden color. Please note these two reactions. When copper is heated in air, it combines with oxygen to form copper oxide. This is oxidation reaction. Oxidation reaction. Oxidation means an element combines with oxygen. An element gains oxygen is known as oxidation reaction. At the same time, in this second reaction, when hydrogen is passed over this copper oxide, the oxygen is removed from the oxygen. This is known as reduction reactions. Again, so the oxidation is addition of oxygen. Oxidation is the addition of combination of oxygen. Reduction means removal of oxygen. Oxidation is gain of oxygen and reduction is the loss of oxygen. In this reaction, copper combines with the oxygen. So copper is oxidation. Copper is oxidation. Copper is oxidation. It is so let's please note the difference. When we write the reaction of, when we are writing the oxidation and reduction reactions, you look only the reactant side only. You don't look to the other. Here, copper oxide, when passing hydrogen over copper oxide, the oxygen is removed. The oxygen is removed. In this reaction, hydrogen combines with oxygen. So, but hydrogen combines with the oxygen. Or in this reaction, copper oxide turns to copper, hydrogen turns to water. Copper oxide turns to copper. Here, which element is combines with oxygen? Hydrogen combines with oxygen. So, hydrogen is oxidized. There are four components. In your test, you also do not play to this. Hydrogen is oxidized. Hydrogen is oxidized. Therefore, the other substance is reduced. In the reactant side, there are only two substances. We look only the reactant. When we are searching the oxidized and reduced substance, don't look on the product side. We look on the reactant side only. When which substance oxygen is removed, or then which substance oxygen is removed. From copper oxide, oxygen is removed. Oxygen is removed, it is reduced. When oxygen is added, it is a reduction reaction. examples in your textbook. For example, zinc oxide when heated with the carbon. Zinc oxide when heated with the carbon, it turns zinc plus carbon monoxide. Here, the oxygen is removed from zinc oxide, so it is reduced. Carbon combines with oxygen to form carbon. It is oxidized. There is one more example. When manganese dioxide, manganese dioxide is treated with the hydrochloric acid, manganese chloride, water and chlorine are formed. Here, which substance is oxidized and which substance is reduced? We can find out. We only note down the reaction side only. Now look at in this reaction, manganese dioxide loses oxygen to form manganese chloride. But substance at the same time, hydrogen chloride reduces to water. Here, in hydrogen chloride, hydrogen combines with the oxygen to form water. So, the substance oxidized. Oxidation means addition of oxygen, gain of oxygen. In hydrogen chloride, hydrogen combines with oxygen, therefore the substance oxidized is HCl. Now HCl is oxidized. Why is HCl oxidized? In HCl, hydrogen combines with oxygen to form water. There are processes. The substance oxidized is HCl. Oxidizing agent is Mn2. That is not given in this room. Then you have to for your information. And if HCl is oxidized, the substance reduced is Mn2, manganese dioxide. Why we said manganese dioxide is reduced? The removal of oxygen. Removal of oxygen. From this equation, manganese dioxide, oxygen is removed from manganese dioxide and it becomes MnCl2. So, in this reaction, oxidation and redox reactions oxidation and reduction takes place simultaneously. Such reactions are called redox reactions. Oxidation plus reduction is gives the redox. Reduction plus oxidation gives reduction. Oxidation means addition of oxygen. Addition of oxygen or removal of hydrogen. Reduction is on the opposite. Reduction means removal of oxygen or addition of hydrogen. And so there are 5 types of reactions. There are so many classification of reactions in our test. So when we see a reaction in this chapter, the first activity given is magnesium ribbon burns in oxygen to form magnesium oxide. The first activity. In this activity, there is a question given to you. When magnesium ribbon is put in a place, what you can see? What is your observation and what is the product formed? In this equation, we can find out all the answers to our in this chapter. When magnesium ribbon burns in oxygen, magnesium oxide is formed. Here, first we look at whether this is what are the reactants. The reactants are magnesium and oxygen. Magnesium and oxygen. You take each chemical reaction, ask these questions and find out the answers yourself. First, you look at what are the reactants and what are the products. This is a chemical equation. A chemical equation represents a chemical reaction. A chemical equation represents a chemical reaction. What are the reactants and what are the products? First question. Reactants are what? Second, you ask yourself, what type of reaction is? We have already studied several types of reactions. Whether this is first is combination, whether this is combination reaction, whether this is decomposition reaction or displacement reaction or displacement reaction. For finding out combination and decomposition reaction, I give you a simple technique. Combination reaction means wedding magnesium weds oxygen forming new magnesium oxide. This is combination reaction. Only one product. So it is a combination reaction. Just opposite to combination reaction, I already cleared to you. Decomposition means diverse. Combination reaction only one product, decomposition reaction only one reaction. For the second name, this is a combination reaction. The other thing is whether the equation is balanced or not. What is the importance of balancing? Here only one magnesium atom, here one magnesium atom, here two oxygen atom, there only one oxygen atom. Hence this equation is not balanced. If an equation is said to be balanced, the number of each atoms on the reactant side must be equal to the number of each atoms on the product side. So first let's say this first balance equation. Here there are two oxygen atoms, so we give 2 here. 2 Mg. Hence here 2 Mg, here also it is 2. Now it is a balance equation. 2 Mg plus O2 gives 2 Mg. It's a combination reaction. Next is we ask whether it is an exothermic reaction or endothermic reaction. Exothermic reaction means excess. The reactions in which heat energy is liberated. We have already seen the activity when magnesium fluid burns in oxygen, magnesium oxide is formed at the same time heat energy and light energy is also produced. So it is an exothermic reaction. Next balance equation, next it is exothermic or endothermic. Next we have to identify whether this is an oxidation reaction or reduction reaction. We now study that oxidation reaction means gain of oxygen. Here magnesium combines with oxygen to form magnesium oxide. So it is an oxidation reaction. Then in your test we also ask what happens when magnesium is put in a flame. Magnesium burns with a dazzling light. Dazzling light. Dear, magnesium burns with a dazzling light. What do you mean of dazzling light? Dazzling light from magnesium and when the magnesium oxide is formed. Well, here arises one more question. When magnesium turbine is put in a flame, we have to clean the surface of magnesium. Why? When magnesium, not only magnesium, any metal exposed to air, it combines with oxygen to form its oxide. A coating of oxide is formed. If, for example, if iron is exposed to air, it is iron oxide is formed. Then iron oxide again combines with hydroxide, present air to form ferrous hydroxide. It is known as rust. So our question is why magnesium ribbon should be cleaned before the flame. Or if magnesium is not cleaned, it does not catch fire. Because magnesium ribbon is coated with the magnesium oxide. To removing the magnesium oxide coating, we have to clean it with the sandpaper. Then another example, another activity is what happens when lead nitrate is added to potassium iodide solution. Lead nitrate. To form lead iodide potassium nitrate. Here, what are the reactions? The science students must always care when you see a reaction, you have to look at what are the reactions. The reactants are lead nitrate and potassium iodide. Products are lead iodide and potassium nitrate. Our second question is whether the equation is balanced or unbalanced. Whether the equation is balanced or unbalanced. You look at here, 1 pp, okay, 1 pp, 1k, 1k, 2 NO3. NO3 twice, that means 2 NO3, here only 1 NO3. So, we have to balance equation. How to balance? Here 2 NO3, therefore we also put 2k NO3. There 2k NO3 comes here, 2k, therefore we are writing 2 here also. Then we again note down whether the equation is balanced or not. 1 pp, 1 pp, 2 NO3. NO3 is a radical. A group of atoms having a charge is known as radical. In your 9th standard, writing molecular formula of substance in page 37 of standard 9 textbook, you have all these matters. You can remember that chapter. Here, nitrate 2, nitrate 2. 2i, 2i. 1 letter, this is balance equation. Then you know when potassium iodide is added together with what carbon, a yellow precipitate of lead iodide is formed. An yellow precipitate of lead iodide is formed. Precipitate means which is insoluble in water. That is known as insoluble in water. We have to study in the second chapter by balancing chemical reaction. If the equation to become more informative, we have to write down the states of the reactions and products. State means whether it is solid, liquid or gaseous or aqueous solution or precipitate. Then there is, we have to note down all the steps we have to study this chapter. We know that this is the reactions are lead iodide and potassium iodide. Products are lead iodide and potassium iodide. Then our next question is which type of reaction is this? That means whether it is a combination reaction, whether it is a decomposition reaction, whether it is a double displaced reaction or it is a double displaced reaction. We have to apply the technique here. We know that if combination reaction, only one product. Here this is two products, so this is not a combination reaction. Whether this is a decomposition reaction, if a decomposition reaction, there is only one reactant. Decomposition means, I already told you, here two reactants, not this is not a decomposition. Our third look is what? Whether this is a displacement reaction. Displacement reaction, we already know that more active element displaces the less active element from a compound. Here only two radicals or ions, nitrate and ion. So it is not a displaced reaction. Then the next fourth reaction becomes double displacement. What is the double displacement? The two reactants exchange their ions. Potassium nitrate, the nitrate of potassium nitrate is exposed to potassium and the iodide is exposed to lead. Two ions exchange each other. So it is a double displacement reaction. So seeing all these reactions, you have to note all these things. The next thing is balance chemical equation. H2 plus, in your textbook given some questions, H2 plus Cl3 gives HCl. This is converted to H2 to balance H2 plus Cl2 gives HCl. We already know that never write H because H hydrogen is a dialkali. Never write chlorine Cl. It is already write Cl2 because it is also dialkali. But hydrogen already is HCl. Whether this is a balanced equation or unbalanced equation, in here hydrogen 2 atoms, chlorine 2 atoms. Here only one hydrogen atom and one chlorine. It is unbalanced. How to balance? When we write 2 here, then again not. 2 hydrogen atoms on the reactant side, 2 hydrogen atoms on the product side. 2 chlorine atoms on the product reactant side, 2 chlorine atoms on the product side. So it is a balanced equation. Which type of which type of reaction is? Again we look at again. Whether it is a combination reaction or a decomposition. What is combination reaction? You apply the knowledge in combination reaction, there is only one product. Look at here, 2 reactants, 1 product. So it is a combination reaction. Then you don't go to the other reactions. You can get other reactions. KClO3, potassium chloride, on heating, it decomposes to give potassium chloride plus oxygen. Look at here. On seeing this reaction, what are the reactions and what are products? Reactions, potassium chloride only. This is a form of energy. It is simply denotes heat. If it is the reactant side, it absorbs heat. If it is the product side, it liberates heat. What are the reactants? Potassium chloride. What are the products? Potassium chloride atoms. Then next we look whether this is a balanced equation or unbalanced equation. Note the number of atoms. Potassium 1, potassium 1, Cl1, Cl1. Oxygen here 3, here only 2. How can we balance equation? Here you multiply 3 by 2. Then what is the answer? 2 KClO3 gives here 2 into 3, 6 oxygen atoms. Here also 3 into 2, 6 oxygen atoms. 2K. Here you put 2K. 2Cl. Here also okay. Cl. Then you again check the question. So 2K atoms here, 2K atoms here. 2Cl, 2 E2Cl, E2 ഇതിലൊരു പോലെ അപത്തി. 2Cl, 2Cl okay. 2 into 3, 6 Cl also 6 oxygen atoms. Then the second step is always over. First is we know what are the reactions and what are the products. Second question is whether it is balanced or unbalanced. Now at present equation balanced, we balance equation. Third is whether this is what type of reactions. Next our question is what type of reactions. What type of reactions. We apply the knowledge. Number of products 2, number of reactant 1. What is reaction? Decomposition. Combination and decomposition reaction can easily identify. If only one product, it's combination. If only one reactant, it is decomposition reaction. Then we next go to decomposition reaction. What type of it is exothermic or endothermic? Exothermic means heat energy liberated. Endothermic means heat energy absorbed. In this reaction, we know that on heating potassium chloride, it absorbs heat and decomposes to potassium chloride. It absorbs heat, so it is an endothermic reaction. This is an endothermic. It is also known as thermal decomposition. By is also known as thermal decomposition. By the reaction is brought out by absorbing heat energy. So it absorbs heat energy and decomposes to give. So it is also known as thermal decomposition. Then there is one more reactions. What happens when barium chloride is added to aluminum sulfate solution? Barium chloride is added to aluminum sulfate solution. What are the reactions here? Barium chloride and aluminum sulfate. What are the products here? Barium sulfate and aluminum chloride. Then our next house is whether the equation is balanced or not balanced. Here only one barium atom, here one barium atom, here two chloride atom, here three chloride atom. The equation is not balanced. You can break it. This is a simple, not a simple equation. Therefore, you can use the table method. In the table method, there are three columns. One name of elements, elements on the left side and elements on the right side. Then you can find the answer. There is, in the case of, first you have to note down that which element has the greatest difference. The number of atoms, which atoms are the great difference. You first you try to balance that equation. Here, SO4 thrice. SO4 thrice. 3 SO4. So you are also right. 3 SO4. When 3 SO4 comes here, we also 3Pa. Therefore, we write 3Pa. Then 3Pa, 3 atoms comes here, you note 6 chlorine atom. 6 chlorine atom, we write 3 chlorine. You write also 2 chlorine atom. Again, I said to you that this is a triatom model. When you practice it several times, you can easily balance any equation. Then you check out it again. 3 barium atoms here, 3 barium atoms here. 3 into 2, 6 chlorine atoms here. 2 into 3, 6 chlorine atoms here. 2 aluminum atoms here, 2 aluminum atoms here. 3 SO4 radicals here also 3 SO4. So it is a balanced equation. First we note what are the reactions, what are the products. Second whether the equation is balanced or unbalanced. If it is unbalanced, we have try our best to balance the equation. The third thing is which type of reaction it is. Which type means combination, decomposition, displacement, double displacement. On first look, we can say that it is not combination and not decomposition. But then we have only one doubt, whether it is displacement or double displacement. Here, 2 ions. The 2 reactants already have 2 ions. Then without doubt, we can say that it is a double displacement. Here, the 2 atoms, 2 elements, exchange there. They are exchanged and form their ions. So, it is a double displacement reactions. Then another equation is when barium chloride is added to sodium sulfate solution. Barium chloride is added to sodium sulfate solution. Here also you apply the process in the previous problem. Barium chloride when added to sodium sulfate solution, white precipitate of barium sulfate and sodium chloride form. In this equation also reactants are barium chloride and sodium sulfate. Products are barium sulfate and sodium chloride. Second, we identify whether it is balanced or not balanced. Here, 2 sodium atoms here. 2 chlorine atoms here. Da1, Da also 1. Chlorine 2, inside there is 2 chlorine atom, so on the product side also you write 2 chlorine atom. Then here also 2 sodium atoms, here also 2 Na, so 2 sodium atoms. So SO4 1, today SO4, S1 O4 also 1, so it is also 1. The balanced chemical equation is BaSO4 plus Na2SO4 gives BaCl2 plus Na2SO4 gives BaSO4 plus 2NaCl. When barium chloride is added to sodium sulfate solution, a precipitate of barium sulfate and sodium chloride are formed. Then the third question is what type of reaction? We already had several examples. On seeing, we can easily identify this is a what type? Double displacement. Two reactants exchange their ions each other. So barium receives sulfate and the sodium receives chloride. They exchange each other. So this is a double displacement reaction. Then one more example. When sodium hydroxide is added to HCl solution. Sodium hydroxide it is also part of the reaction phase. Sodium hydroxide is an acid. Sodium hydroxide is a base. HCl is an acid. A base reacts with acid to form salt and water. Base acids react with bases to form salt and water. Here one sodium atom, here one sodium atom, one oxygen atom, two hydrogen atoms. There are also 2 hydrogen atoms, 1 chlorine atom. This is already a balanced chemical equation. In your textbook, several questions are given to you. In each chemical equation given in your textbook, you have to take out one by one, write your notebook and try to balance each other. When you try to balance each other, you ask these questions. What are you learned in this chapter? First is what are the reactions, what are the products. Second major question is whether the equation is balanced or not balanced. Third type of question is what type of reactions. Reactants, products, balancing the equation and what type of reaction it is. And the last one is whether it is oxidation or reduction reaction. So these reactions, you try to answer these questions in the given textbook. In the next class, we can discuss the other topics or exercises. 2 small topics also given at the end, corrosion and rancidity. We can also discuss the next episode. Thank you all.